Welcome to the show for Mangal Earth actors. Here we transverse the universe of space exploration and green jobs. You know who I am. I am Bhuvan Verma, your host. And following the Oscar rule, we will get responses from our speakers, subject experts who come to the show to share what they have done in space science and sustainability and talk about issues or factors contributing to the problem solving genius that our guest speakers are. So, without further delay, let me tell you. Our speaker today is someone very special, Abdulrahman Alfauwaz, a brilliant researcher and scientist, a country with world class infrastructure for space exploration comparative to its size. Hello, Abdulrahman, how are you?
Thank you for inviting me to your show, and I hope I'll answer your question in this episode. And we hopefully we go over all the questions that you have. I'm glad to present here Saudi Arabia in Riyadh. Now we have really a booming space industry, so I'm glad to represent them in this show.
Abdul Rahman, you are a prolific researcher with extensive experience in space missions and cutting edge technologies. Your work has contributed significantly over the past several years. Tell us what are the main objectives of your current research project and how do they aim to address the key challenges in space engineering and sustainability?
My background is aerospace engineering, but for my research, I'm focusing on the satellites design and payload design, etc. Studying the orbits, the dynamics for the satellites, how we design the orbits for our satellites, and the sensors that we need to improve our satellites. So I'm focusing how we reduce the disturbances on our satellites and our measurements, and also how we protect the payload for our satellites from any disturbances that we might have in space.
And solar flares have been known to take out satellites into operation, but not
Yeah.
stopping there. Getting quickly into our next question to you, Abdul Rahman, your past work includes groundbreaking research on photoelectric properties for passive charge management using LEDs, which has
Yes.
important implication for space missions. Can
Yeah.
you tell our viewers on the benefits of using UV LEDs for charge management in space missions and what improvements they bring over traditional methods?
First, let me talk about the ultraviolet light. It's electromagnetic radiations, and it's the wavelengths. It's around 400 nanometers. So, what the benefit of using this source of UV light? It's we use it in space to compensate internal disturbances for our test masses that it's inside the spacecraft. Because inside the spacecraft and even in space, we have a charged particle that is affecting the accuracy and the precision of our sensors. So using the UV, using it in space, can be getting a benefit of reducing these disturbances, compensate these internal disturbances to our test masses by doing charge and discharge of test masses. Charge of test mass. Yes.
I always understood that ultraviolet light was used on Earth to remove
Yes.
any germ contamination and so on. There are new gadgets that were being made during COVID also. But
Yeah.
taking off from here, your experience in using UV LEDs in space. Tell
Yeah.
us, conducting research in space provides unique opportunities and challenges that cannot be replicated on Earth. And not even with AI, I guess. You
Mm.
have to be there in those elements. How does, please tell our audience, how does conducting research in space enhance our understanding and capabilities in space engineering? And what are some notable discoveries, innovations that have emerged from space based research?
As you said before about the UV LED. Most of our technology that we are using now for space is starting from the Earth. But using it in space, it's improving a lot of, giving a lot of advantages, and we can improve our technology by using it in space. For example, the UVLD, the first time we run it in Saudi Sat 4, it was 2014, and it was demonstrated to work in space environments, and it can be used to discharge and charge the test masses. But to answer your questions, yes, we have a lot of notable discoveries. It's only from the space applications. I can give you an example of NASA Jet Propulsion Laboratory. They worked on scientific quality cameras in 1990. And now, 1/3 of all cameras that we are using, it's based on this technology. Also, baby formula, it's based on the space answers in space. Because there are limited resources of the food in space, so they use this technology to have this food ready for them in space. So we use it now for our babies as a formula infant. So that we have also other discoveries that it's based on space work or space research or space experience. So I think the space can be used as a tool to even improve our life here on Earth by improving our technology, by having more, more technology that's usable for everyone here on Earth.
As Abdul Rahman, you mentioned, all of these examples, from the digital to food and nourishment that is critical for our survival. The future of space engineering is evolving rapidly with the integration of new technologies, new methodologies, new paradigms. How can sustainable practices be integrated into space engineering, and what are the potential long term benefits for both space exploration and environmental stewardship on Earth?
Yeah, so to answer these questions, let me first start that the technology in space need to be have new roles that it's taking care of the sensibility. Because, for example, I can mention to you and to the viewers that we have the problem that might increasing in the near future, the space debris. And the space debris, it's based on our use of satellites in space, and it's sometimes it was sourced by collisions or other sources. So how we can remove it? This is one of the issues that we are thinking about it. Also, using a green propulsion to have a cleaner environments in space for our satellites and spaceships. So how we mitigate these? We need to have a new specification, new policy, how we remove the space debris, for example, how we have a policy that for everyone to use the space,
Right.
because this is really a very important thing that all the governments, the companies need to sit together and work on these issues.
Definitely. And hopefully, in the near future, just like we have biodegradable materials, maybe Riyadh will come up with a space degradable material out of which, these materials will be made, because, velocity of a drop of water and metal is the same in space because of
Yeah.
huge distances and speeds. So, all the best to you, and taking cue from these high end technologies that Abdul Rahman, you are working with. We are really privileged to have you on our show, where you are able to flex your muscle and tell us what we are doing in the country for improvement. Tell us your work on high precision accelerometers and magnetic levitation systems. This is a passion for me. After having written book on Mars colonization using magnetic levitation. So tell our viewers also that how do these technologies contribute to the broader goals of space missions and scientific research?
Let's first talk about the high precision accelerometer. So most of the satellites or the space missions use accelerometers, which is a very high precise sensors for different applications, for navigation satellites, for geodesy science missions, or even for drag-free satellites that it's need to use a very high precision accelerometer. So my focus now in this sensor, because of the we have a current precision that it's limited for several reasons. We need to come up with a new sensor that it can go over these constraints or restrictions. So now that's why I'm working on optical sensor that it can be used as an high precision accelerometers, and it's also will use the UVLD to remove the internal disturbances, etc. So this is a very important research that I'm working now on this, and I hope, inshallah, we will have results for these type of sensors. For the magnetic levitation system, because I'm working on the space applications and space-based work, we need to simulate a zero-G operation here on Earth. We have a gravity here on Earth, but we need to remove or at least have a zero-G operation for our structure or our work. So that's why I have this also done as a tool to be used for instruments to simulate the zero-G operation here on Earth in vacuum chamber, in vacuum environments. And it was working fine, and inside the vacuum, we can levitate test masses and spin it, and we can have study it and take the measurement that we need or do whatever we want in our applications.
Friends, rewind this section, this last question of use of magnetic levitation and of using high precision accelerometers is dense packed with knowledge. You will learn something new throughout this conversation. I want to express my sincere gratitude to Abdulrahman for joining us on Mangal Earth. Abdulrahman, your expertise and insights into space engineering were invaluable. Your passion for the field is visible in the contributions that you have made and the wide range of activities that you involve yourself in. We hope to connect with you in more such interesting conversations, further detailing, so that we can get to an answer quicker. I am excited to see how your research will broaden our horizons and shape the future of space exploration. Thank you again for sharing your knowledge and time with our friends. Keep sharing this video with peers. Mangal Earth.